Hello everyone, myself Dr. Susana Johar, RP Assistant Professor in the Department of CSE AML. Today I'll be going to explaining the Artificial Intelligence Lab program number 2, that is implement AO star search algorithm. Just have a look what exactly the AO star search algorithm is. It is also similar to the best first search algorithm where we are going to finding the shortest path between the source and the destination node. What exactly it does? It will divide any given difficult problem into smaller group of problems that are then resolved using the AND-OR graph concept. AND-OR graph are specialized graph that are used in problems that can be divided into smaller problems, and AND side of the graph represent a set of tasks that must be completed to achieve the main goal, while the R side of the graph represents the different methods for accomplishing the same main goal. For example, if you want to buy a car, there are two methods, AND approach or R approach. That AND approach is nothing but get a car. In order to get a car, what we require, buy with own money. That is the AND approach. That means both the things should be positive, then only you can buy a car. Whereas the R approach is something like you have to steal a car. So that is what the R approach. In the above figure, buying of car may be broken down into smaller problems or tasks that can be accomplished to achieve the main goal in the above figure, which is an example of AND-OR graph. So the other task is to either steal a car that will help us to accomplish the main goal, or use your own money to purchase a car that will accomplish the main goal. And symbol is used to indicate AND part of the graph, which refers to need that all sub problems contain the AND to be resolved before presenting the node or issue may be finished. The start state and the target are already known in the knowledge-based search strategy known AO star algorithm, where the best path has been found out using this heuristic technique. The informed search technique considerably reduces the algorithm time complexity. AO star algorithm is far more effective in searching AND-OR tree than the A star algorithm. Working of the AO star algorithm is as follows. Here also we are using the heuristic function called as f of n, which is used to calculate the lowest cost of the function of the transversal path. Here this is consist of the sum of two cost function, that is g of n and h of n. It is the actual cost and the estimated cost sum. What is the difference between A star and the U star algorithm? A star algorithm and U star algorithm both works on the best first search algorithm. They both are informed search and works on the given heuristic values. A star always gives the optimal solution. Star always gives the optimal solution, but Evo Star doesn't guarantee to give optimal solution. Once Evo Star got a solution, does not explore all possible paths, but A Star explore all paths. When compared to A Star algorithm, the Evo Star algorithm uses less memory. Opposite to the A Star algorithm, the Evo Star algorithm cannot go into an endless loop. Here is the scenario in this particular example where we are going to finding the shortest path among A to J. As you can see, A, B, C, D, E, F, G, H, I, J. These are all the nodes from start from A end with J node. Here, what exactly we are going to finding is that we are going to finding the best possible path. Here, as you can see, in from A to B, there is a cost function associated in order to travel around the network. Across the network, it consumes the cost of 6. As you can see, from B to E, it is 5, and it is from within E, traverse across the node E, it is 7. Similarly, for F, it is 9. Likewise, it is to transfers from node A to D, it is taking the cost of 8, and similarly across the node itself D, it is taking 4, and similarly from D to J, it is taking 0 as the cost of the function. This is the illustration of this. Here in the example below, node which is given in the heuristic value of h of n, edge length is considered as 1. Start from node A, we are going to calculating the cost associated with the function. From A to B, whatever the cost associated with G of B and H of B, it is calculated from this graph. As you can see, it is the cost associated from A to B, it is 6. That is what here it is mentioned. As you can see, this is the cost of this A to B transverse as 6. Similarly, for A to C and C to D, G of C, G of H of C, and G of D and H of D has been calculated, and the cost is getting as 8. As you can see here, it is 8. Similarly, by calculation of A to B path chosen, which is the minimum path, that is f of E, the cost associated with it is 6. Whereas from A to C, A to D, it is associated with the cost of 8, which is more compared to the previous path. According to the answer of step 1, explore node B, here the value of E and F are calculated as follows. For B to E, the cost associated function is 8, whereas from B to F, it is associated with the cost of the function it is 10. So by calculation B to E and B to F, the conclusion we can make is that heuristic for A must be updated due to change in B is heuristic, so we need to calculate it again. So F to AB, it is nothing but the G of B and the updated H of B, it is become 9. So earlier the cost associated this function it is 10, now it has been calculated as 9. We have updated all the values in the above tree. So that is why this is what the solved graph which we are getting after updating all the node values with the associated cost function. By comparing F to AB and F to CD, we can come to the conclusion that the f of a to d shown to be smaller because it is having the cost it is 8 which is less than 9. Now explore to a to d is that the current node is c. From f of a, the function of the cost associated from c to g it is 4, whereas from c to I it is 2. So here we have added h and I because they are in AND. F of c to I have been collected where it selected as the path with the lowest cost, and the heuristic is also left unchanged because it matches the actual cost. Path h and are solved because the heuristic for those path it is 0, but for a to d needs to be calculated because it has AND. For d to j, it is calculating the cost. It is between g of j and h of a. The cost is getting around 1, whereas for a to d, it is getting the cost of 5. As you can see from a to d, the solved and this tree has become solved tree. Now, in simple word, the main flow of this algorithm is that you have to find firstly the level first heuristic value and then level second. After that, update the values going upward means toward the root node. In the above tree diagram, we have updated all the values. So this is the source code or the program code of this function. Initially we are giving the condition for all the nodes with respect to the and the or logic as we mentioned. After that, we are going to updating the cost associated with the function by calculating g f is equal to g plus h of function. This is the code through which we are calculating the cost associated with the each transversal path, and then we are going to printing the shortest path among all the nodes. Once we find out that cost of the function associated with all the possibility node, finally we are going to printing the node. Here all the heuristic values of the node which we have printed here associated with respect to that tree. So finally, once we run this code, this is what the shortest path we are getting here. So finally, we can conclude that AO star search algorithm is a path finding algorithm and it is similar to A star. Other than AND is used between the two nodes along with R. After getting shortest path, it will return back to the root node and it will update its heuristic value. It is similar to the depth first search algorithm. It will search shortest path using the heuristic value assigned to the node, actual cost from source to the destination node. So let me move on to the simulation part. As you can see, this is the source code of that over the Jupyter Node compiler. Here also what we are doing, here we are going to initializing the what exactly the start node and the destination node. After that, we are going to initializing all the nodes as you can see here and printing the graph solution with all the values. And finally, after that, we are going to finding the cost through that cost function. G f is equal to g plus h of s through this code, and finally we are checking that condition, and finally we are calculating what exactly heuristic value and what will be the possible solution through this code. So once it is get solved, get with the possible solution, here is the heuristic values of this function. As you can see, what will be the heuristic values of the tree, whatever we have traced just now over the presentation, and what will be the solution. The processing node is A, similarly for B, similarly for A, what will be the cost. As you can see, as the iterations are changing and varying, then the cost associated with the tree keeps changing, and finally we reach with the optimal solution to this particular problem. So we are getting the possible optimal solution as the from the graph solution, transfer the graph from the start node. The possible solution it is that is E F D E F A. E F D A. This will be the best possible optimal solution associated with this AO star algorithm. Thank you.